You have a last speaker for the evening. Let me remind you that you can ask your question in the chat. Don't hesitate. So the next talk is entitled "Demystifying Shiny Models by Turning an Existing Bigfoot Sightings App Modular." I'm very pleased to introduce Deepsha Milrani, Data Science Manager at Microsoft. Where her work focuses on investment impact analysis and customer proximity modeling. So she's passionate about improving her data visualization and storytelling skills. Thank you very much for being here, and the floor is yours.
Awesome. Thank you, Mana. So today, as Mana mentioned, I'm going to talk about how I learned modules by turning an existing monolith Shiny application into a modular application. So I'm going to talk about a Bigfoot sightings app that I created. What is Bigfoot? So for folks in the United States and others that might already know, Bigfoot is a mythical, gigantic, hairy creature that people within the United States have claimed to have spotted in, let's say, the woods and forests and mountains. And so I created an app to note down where all they have been spotted. So we're going to try to create that app in a modular approach. So first, I'm going to just talk about the two components of Shiny we're going to touch, which is the base components. You have a filter, you update certain filters, and your application and our components of application get updated. So if you have learned Shiny already or are learning Shiny, you would have noticed that the first application that you create is usually this simple application where you update your on the scroll bar the number of bins, and your histogram gets updated based on that number of bins. If you look at the code for the Shiny application, the basic code, there is a UI component and there is a server component with multiple things within the UI and multiple calculations within the server side. Now, this is your usual monolith way of writing your Shiny application. So when you see the code for this app, it's barely 30 lines of code, very easy to understand and learn from, a great first application to start with. But when you move to creating your actual live applications, you can make really large applications very quickly, can go up to thousands of lines of code. And when you create such a large code of a monolith code for a Shiny application, it makes Bigfoot very confused, even with its large size brain, because such applications are extremely hard to read and keep track of components. If something fails, you have to go and find within that thousands of lines of code, fix it, and rerun the whole application again. So it's difficult to debug. If somebody new comes in to contribute, it's just plain mean to them to have them read thousands lines of code and be confused about where they can contribute. And also, it's hard to reuse elements without copy pasting. And this is where modules come into play. So think of Shiny modules as if Shiny and functions had babies. And what does that mean? Let's see. So this is the application we're going to try to create. You have a drop-down for the state in the United States. There are top 10 counties where Bigfoot was observed in that particular state and yearly sightings within that state of how it has gone up or down. And why did I create this app? Because the business scenario is I want to know where I should move next to spot my Bigfoot because I'm a Bigfoot enthusiast. So I wanted to know where to go. So the first thing when you do thinking modules is decomposing your Shiny application. So let's decompose this app. There are three primary components. The first component is where you create the dropdown, let the user select the state, and your data gets filtered based on that. The next module is your county plot, which is built on your filtered data. And the third component is your yearly sightings plot. So once you have identified the three components, let's look at what those components look like within your app.r file of Shiny. Now, don't worry about reading this entire code because everything is available in the GitHub repo, and I will specifically highlight what parts I want you to look at. So let's look at what are the three components within my app.r file. The first one is my UI component of dropdown, and on the server side, I have the data filtering. The next component is my UI look of my county plot. And on the server side, I have the ggplot2 code for creating that county plot. And similarly, my third component is the UI for yearly plot or the sightings over time plot. And on the server side, I have the ggplot2 code for that. Once you have identified the three different components, think about modules as creating 3 different baby Shiny application functions for all 3 components. And that's what modules are. So we're going to create 3 modules, which is 3 baby Shiny app functions, and corresponding to those 3 components. So the first one, the dropdown and server filtering code. The second one for the county plot, and third one for the yearly plot. Let's look at what that code looks like and what are the similarities between a Shiny app and a modular app. So again, I'll point to exactly where I want you to look at. Don't worry about all the code here. So this on the right-hand side, I have only the first module, which is a simple Shiny application module where all it does is show a dropdown, you select the state, and your data gets filtered. That is all the Shiny application module does. So first, let's talk about the similarities between the original app.r file and a modular Shiny file that you create. So the first thing is both of these have a UI and a server component, right? Because at the essence of it, your module is a Shiny application. The second similarity between those two is you see this UI code to create a dropdown is the same as creating a dropdown in your module.r file. And similarly, on the server side, you're filtering this data. Just like that, you will filter the data on the server side here. So no difference there. Now, let's talk about what makes modules unique and important. So the first thing is in the modules, you see that this is a function, and that is what makes modules easy. So what do you mean by function? When I update this original app.r file, instead of writing this whole code, I'm going to just call this UI module function and say, hey, I'm not going to write this dropdown code. I'm just going to call this function, go create this dropdown code for my state selection. Great. On the server side, I'm going to call the server module function that filters the data. So I'm going to say, hey, go take the state that a user has selected and then go filter the data instead of writing the actual filtering code right here. Now, the next important part is in modules to know is an ID. So if you see in my function, this first thing that I'm inputting is an ID. Now think of ID as a blind date. What do I mean by that? So let's say if the UI calls, in my app.r file, I call the UI function that says, hey, go create a dropdown for the state. Great. Done. On the server side, I say, hey, go filter my data based on the selected state. But the server function says, but where do I get the selected state from? I am a server side function. I don't know what UI function to go to. So the UI function call says, all right, I'm going to be holding a red rose, and that's how you'll come find me. So only take the state input from me because I'm holding a red rose. Then the UI says, but how do I know that you are the function call, you are the server function call that I need to hand over my state input to filter the data and not this other server function call? So the server function call says, all right, I'm also going to be holding a red rose so that you know that you have to hand it to me. And that is where the UI and server calls, if they need to talk to each other, need to have a unique ID. The ID is not given when you're creating the function. The ID is given when you're calling the function. And I'll give an example of that in a second here. Now, the next important thing to note about modules is that it has a concept of namespace. And as it suggests, it is a space for the variable names associated with that ID. Now, this is extremely important for not creating conflicts. So let's say I and Mauna are working on the same Shiny application. I created a dropdown for using a state input for one plot. Mauna created another dropdown for using a state input for another plot. Now, my UI function call is holding a red rose. Her UI function call is holding a yellow rose. So the state input variable name that is same in both of them won't conflict with each other because they're associated with two different IDs. And that is the concept of namespace associated with an ID. So here I create the namespace and then I put my variable names inside the namespace so that they then get encapsulated, associated with whatever ID you call the function with. Awesome. Now that this concept is hopefully clear, we have built our first module. Understanding the similarities and differences would help you translate the original monolith app to your module. So we've created the first module. Let's test it out. And that's just a good practice to create baby modules, make sure they're working before you start calling them from the main app.r file. So this is a module underscore input.r file in which I've put my UI function and my server function that I created for my dropdown. So let's create this test app.r file that'll call those modules to create this Shiny application, this basic Shiny application. So first thing we do is we source that module.r file that we just created. The next thing, we have a UI and a server within our app.r file. So in the UI, instead of writing the dropdown code, I'm just going to call that module underscore input underscore UI function, this function that we created, and I'm going to give it the ID input underscore test. The next thing I'm going to do is on the server side, I'm not going to write the code for filtering. I'm just going to call the server function that I've created, this function, and say, hey, go filter my data. This is my data set. And it would say, okay, where do I get the state input to filter the data from? It says, it gives it the ID of input underscore test, which is the same ID we gave to the UI function call. And that is how the data will get filtered. And just like that, we've got the Shiny application created with module calls. The fun part of modules has still not begun. Cool, we can do that. So how is it different from functions? So to come to that part, let's create the entire Shiny application with purely modules. So we've created the first module for the dropdown. Now let's create the second module for the county plot and the yearly plot. I'm not going to go over the code for this because the concept is exactly the same. You write your UI and server as functions. You give it an ID. You put in a namespace for all the variables names that you're going to have. And the rest of the code is pretty similar, which is creating a UI space and creating the server ggplot code. Next, you've got the module yearly plot created, which is a sightings timeline plot. And just like that, once you have the three modules created, let's look at what a modular Shiny app would look like, an updated app. So this is my original app.r file, single UI, single server with all the code for dropdown and plots directly within the UI and server. This on the right-hand side is now the modular approach. So the first thing, I'm going to source the three module files that I have created so that I can call those functions. Next, on my UI side, I'm going to call my first UI function, which is for creating the dropdown. On the server side, I'll call the server function to filter the data. And note that they have the same ID. Next, I'm going to call the county plot UI function and the county plot server function within the server, making sure that they have the same county plot ID. This way, whenever this county plot is created, the plot per county is created, it knows that this is the UI where it needs to put it at, and that is how they talk to each other. Similarly, for the yearly plot that we have created. So this now app is created. It is so much cleaner to read. You don't have the direct code. Now, let's say if your county plot fails for some reason, it isn't getting updated, you can just go to that module.r file, just run that baby Shiny application and test to see what's going wrong instead of finding in the 1,000 lines of code where it is, changing whatever is needed, and then running the whole application all over again. So that's the advantage of modules. There are more advantages that I'll get to in a second here. So this is my application. I created it. It looks exactly the same. The only thing I changed is the underlying structure. Now, what if I wanted to create an app that does this, which is I want to compare two different states? Why do I want to do that? Because let's say Washington as a state has gotten very rainy and gray for me most of the year. So I want to move to a different state, but I also want to make sure that there are Bigfoot sighted in that state because, as I mentioned, I'm a Bigfoot enthusiast. So let's say I don't want to compare two states. I want to compare 10 states. Now, in your original monolith app, what you will do is you will copy that drop-down code 10 times. You will copy that county plot ggplot2 code 10 times. And similarly for the yearly plot code. Now, that is extremely tedious. And let's say if you want to update this bar plot to a scatter plot, you will have to go to all of those 10 places in your monolith app, update the code to a scatter plot in all of those places. Again, extremely tedious, and you can end up making a mistake if you missed some color changes in one of the plots instead of updating all the plots simultaneously. This is where modules really shines. So this first part of the module calls for the dropdown, the county plot, and the yearly plot. And similarly on the server side, the filtering, the county plot, and the yearly plot. Those will create my top row. This second set of module calls will create my bottom row. And that is how quickly. You can just call the modules again and create as many drop downs as you want, call the modules again, create as many county plots as you want easily instead of copy pasting the entire ggplot2 code. And if you want to update the bar plot to a scatter plot, you just go to that module and it'll update in all of the module calls, it'll create a dot plot. Now note that unique IDs here are unique to each module call separately. So in this first one, the drop-down UI has inputs ID and the server side data filtering has inputs ID. My second dropdown has inputs underscore 2 ID, which is why I gave it a different unique ID. And so my county or my data filtering call for that server function also has an inputs underscore 2 ID. Now, why is that important? Because here you can say that if I give this and data filtering the same ID, then whenever I update this state, my this county plot will get updated. And the reason I'm giving that example is because I made that mistake while creating this application for these slides. So do as I say, not as I do. Awesome. So to bring it home, the concept is you had a monolith original app and you had a UI input, a plot display UI, and you had a data filtering and a plot server code. You basically converted that into multiple components. You created an input module R file that just creates the dropdown and filtering, and a plot UI file that just creates the display and the plot code. And then instead of having the monolith app, you started calling these modules as functions. And that is the primary difference. Now, if you remember, the confused Bigfoot is now much happier because you can finally keep track of components. You can easily replicate or debug if something fails. And if someone new wants to come in and contribute, they can easily read your code to be able to start contributing independently to that Shiny application. You can also reuse elements of the Shiny application within and across. Just some resources to get started. If you are new to Shiny, I highly recommend learning this the modular approach way. I didn't, and it is slightly more effort to do that, but it is not as advanced a concept as it is put in a lot of resources. So it takes a bit of time to pick up, but it is better for the long term to be able to build large scale applications. If you have already started the monolith way, which is how I did it for years, I built monolith way till I heard about modules, which has existed for decades and I just didn't know about it. And so instead of learning modules from scratch, I took an app, converted it into modules to really bring home the concept. And both the modular and the non-modular code is available in the GitHub repo for you to be able to look at the differences. And of course, shout out to the Mastering Shiny book by Hadley Wickham, because that's where I learned so many of these concepts. Awesome. That is all on my side. Hope this was helpful.
Yeah, thank you very much. Very well structured talk and impressive one as usual. So let's now move to the questions. You have one first one from Eli. So is it possible to use modules with Shiny Express? So did you use before?
Great question. I'm not sure. I know Shiny Express is there for Python now, but for Shiny for Python, the basic way, the original, or they say core Shiny, I do remember, and I would need to confirm that, but I do remember a blog from actually someone from Epsilon had written about how to use modules within Python. But I am not sure if, and I'm also curious to know if it works with Express.
Yeah, thank you. So we have a second question. How does using models can affect error handling and debugging in Shiny applications? Like, are there any tips for troubleshooting issues that arise within modules?
Yeah, so I had created separate tests for separate modules, and that is what was the advantage in making each of the tests simpler. So think of each module as its own Shiny application. Like I would treat just the county plot independent of everything else and just be able to test that Shiny application by itself. So that is what made it more palatable for me to be able to debug components. Great question.
Nice. So I think that was in the examples. So Martin is wondering if data filtered and data filtered to are reactive.
Yes, they are considered reactive. It's treated slightly different in modules. So you will see the parentheses in that you're used to giving in the monolith way. You will skip those parentheses, and some places where and vice versa. Frankly, that part I always Google because I forget where the parentheses go there. But yeah, that is exactly how it's treated.
Yeah, wonderful. Thank you very much. If you have any more questions, don't hesitate to reach out to Deepsha. So I think you are out of time. Thank you so much. So this is the end of the day for today. You hope you found the Shiny conference as exciting as you do. Let's now move to the stage one for the closing remarks.